Hello and welcome to Netcode for GameObjects. This is going to be a casual and quick playthrough of a project that I did, looking at some of the multiplayer options, choosing one particular one, and making a simple demo, stepping through a couple different stages. My name is Samuel Asher Ravello. I am a Unity certified game developer. I have over 20 years of game dev experience, the last decade or so with Unity. My mission is to both educate and entertain with interactive technology, so I love both creating games and tools for gaming, as well as talking about them, educating, and doing classroom and teaching as well. So I'm available for remote contract hire, both as a Unity game dev and also a Unity game dev instructor. And here's what we're going to take a look at today. A single player version of this simple game is what we'll start out looking at. I'm not going to show how I created each of these. I'm just going to step through the current state of things. So some prior knowledge is definitely needed here. But as a high level introduction to game dev and what parts of the essentials of game dev are covered in this simple example, here you have a character, you're going to be moving it around, you can push this crate. Every time you touch a crate, you get some points. Very simple. It's not fun per se. It's not a core game loop that you'd really want to expand on, but it's just covering some of the basics here. We've got user interface, we've got taking input. I'm using the keyboard, but also a gamepad would work fine. I don't have any audio in this one, but audio would be an essential for a typical game. There's graphics being rendered, there's animation for the character, as well as programmatic animation of each of the sprites moving around the screen. And then of course there's scripting. So missing audio, the rest of it is there, and it really represents a good demonstration of what will eventually be multiplayer, but here's the single player version. Then what I'll do is use Unity's Netcode for GameObjects, which is Unity's first party official solution for how you should do multiplayer gaming. It's one of many options. And in it, I can spawn more than one game window and play against myself locally. So each time I spawn a new instance, for example, here I got 4 different of the versions of the app spawned. One would be the host of the game, and then there's going to be 3 clients. So with this version, it's a client authoritative version, meaning that each client takes care of itself more or less. We'll compare that to the next version. I created a quick lobby, which is a custom implementation of how these players would join into the same match together. And then I'm syncing the objects using client network transform, which is a hacky version of the network transform and allows me to do client authoritative movement. Now, client authoritative stuff is easier to implement, but it doesn't quite scale to the professionalism and the security you would need for a real production game. There you're going to want server authoritative. So in a server authoritative environment, the host, which is one of the instances in the room, has a bit more authority, a bit more control, a bit more power, and the rest of them kind of look to that host to manage the game state for them. So here, instead of each client moving themselves around, each client is going to be asking the server, hey, can I move a little to the right? The server says, yeah, and then the client moves to the right. This is more secure for a lot of different reasons. And here I'll be talking about the quick lobby is still there. I also use some network syncing of the objects around. I have network variables, which is a NGO specific feature that allows you to set the score and the name of each character, let's say that's on the screen. And then there's also remote procedure calls, which is what I use to move the character. So in the client version, you click right on the keyboard and the character moves itself in the typical Unity way, the single player way. Using the remote procedure call, when you click on the right arrow to move a character, if you're one of the client doesn't move itself. It says, hey, server, can you move me? And then the server moves it. So there's an extra check there that is better for security so that you can't have your players hack. There is a lot of different options for when you're creating a multiplayer game. This is a partial list, right? So we've got Unity's official multiplayer networking, which is called NGO, or Netcode for GameObjects in our case. You've got Coherence, Photon, Nakama, Mirror, Normcore, Fishnet. Those are the ones you see most often. Then I found a few other randoms, ZapNet, ObjectNet, this easy multiplayer for Vector. These are some of the ones that are on the App Store. This is a partial list. There's tons of them out there. I think when a lot of people approach looking at multiplayer solutions, a question that they ask is, well, how many concurrent players can I have? Can I build a world that has 100 players at the same time? Or can I build a world that has 1 million players at the same time? I think that is putting the cart before the horse. It's not really that important because probably the hobby game that you're working on will never have an audience of that size. So while it is a consideration, I think ease of use, how easy it is to implement the features that I need for my game in Unity, is far, far more important. So I encourage you to look at ease of use as one of the features to consider when you're comparing these different options. Then I found a fantastic spreadsheet that takes the mirror, fishnet, and the Unity's netcode for GameObjects, those 3 columns there, and it goes through tons and tons of different features and how you might compare them and defines them. So I won't go through it all, but here I'll just pick out one for them. You can have, let's say, the Unity transport layer, which is the way to move your data back and forth. That is one of the rows here. It continues and has things like, does it support timers? So server-side timers. Then there's even more things here. You can pause and take a look at it. Rigid body prediction, transform prediction. Which one does it have? It says the NGO has no transform prediction, but I don't actually think that's accurate, at least not from my knowledge. But you can see there's tons and tons. There's another one. So I think this is the full list over the course of these slides. So for example, custom conditions, lag compensation, et cetera, et cetera. I noticed that some of the features are paid and not paid for Fishnet and Mirror. NGO is completely free to implement. And then once you would put it into production and have actual users, then there's some price to be paid there. But it's fantastic to get started for free, and that's what we're doing today. So I want to do a special shout out. I've played with Photon, Nakama, Coherence, and Unity's multiplayer solution most. I have never done a production multiplayer project in my career. I've only done single player experiences or single player experiences with social features that are more asynchronous, like high score tables and stuff like that. But I have indeed played around with them a lot. And I did do some professional work with Nakama, actually, now that I think about it. I created their onboarding documentation for an earlier version of the Nakama Unity server and created a complete game with that. So that was cool. But I want to give a special shout out to Coherence, which is one of the newer ones on the block here. And it has absolutely fantastic tooling inside Unity. It really makes you feel like the multiplayer setup you're doing is specifically for Unity. Quite a few of these are, but quite a few might work for Unreal and Unity, for example. So there might not be as much Unity specific features. But the tooling in Coherence is fantastic. It really feels like it was designed for Unity and has all sorts of WYSIWYG panels that help you explore the features and stuff like that, removing a lot of the boilerplate code that you would need to do. While Unity's NGO, which we'll talk about most here, is created by Unity for Unity, they lack a lot of the nice to haves that Coherence has. So Coherence is a fantastic one to look at. But we're looking at the Unity multiplayer networking. Now, Unity multiplayer has gone through several different versions and several different names. The most up-to-date one, which is the only one Unity recommends, has 2 flavors: Netcode for GameObjects for most of us, and Netcode for entities, which is for a DOTS project. We won't talk about that second one. So we're talking about multiplayer networking for Unity, or NGO, or Netcode for GameObjects. Those are all the same words for what we're going to be talking about here. And if you go to Unity's official website and click on the, hey, can we do multiplayer with Unity? It's the one and only thing that they're going to showcase here. So this is a representation of their website. And you can build multiplayer games with the Unity netcode. So the netcode part of the name Netcode for GameObjects talks about the server side that helps keep everything working. We're dealing only with client-side stuff here. It feels very much like we're writing regular old C# sitting inside our Unity editor, but some of that is actually going to talk to the server or even run on the server in the case of remote procedure calls. So there is a lot of documentation. I think I played first with the Netcode for GameObjects before it was in 1.0, maybe 2-3 years ago, a little bit. And then what we're building off is the latest version here, which is as of today, it looks like 1.8. and then there's some different version numbers on there. I'm doing it in Unity 2022, the latest LTS release, but there's a little bit as you go through the docs, they'll talk about some things that are only Unity 2023. I'm not touching on any of those. Everything we're talking about works for both of them, but just know that they are adding some features for 2023 only. So a brief introduction on where multiplayer fits in. So in the software development lifecycle, which in making a game takes you from everywhere from I have an idea, which is in the requirements analysis, you figure out kind of what you want to satisfy, what kind of needs you want to create there, all the way through planning the project, designing it, finding the assets, in the development phase, and number 4 here, that's where we spend the bulk of our time, calendar time probably. That's where you're writing all the final code and bringing all together all the assets, doing all the game mechanics, and then you're going to be iterating probably through all these steps several times. It's not necessarily that 4 comes completely after 3. You'll do a little design, you'll do some development, you'll pop back and do some more design. You can see it's cyclical. But in the development, testing, and deployment, that's where we're spending time inside Unity and spending the most of our time creating and testing stuff. So a special shout out I want to mention here is this represents what would be a single player experience, this diagram. I'm going to pop ahead here. That there's a little bit of an extra hiccup when you're doing multiplayer testing. I can spawn my own one instance of the game, which I'll try and call the app build, because I don't want to say the client, because the client has a special name inside the multiplayer world. We talk about the host being one of the people in the room and the clients being everyone else in the room. And the host has some additional responsibilities, at least the way we're setting things up. But in the testing phase, I'm showing here that we want to spawn more than one window, probably. We want to have more than one of these app builds. And that's so that you can play against each other or play against yourself as a dev. You at least want to spawn 2 windows, I find. And that's probably what I'll do when I step into the code here. The reason that you do that is because a multiplayer game can't really be tested unless you have multiple players in the multiplayer session. Even if that's 2 windows on my own desktop and I move a little bit here, move a little bit here, you want to see that things sync up properly. So there's 2 ways you can do that. Well, let's say there's even more. In the code, I step through quite a few. But one of them is I just do a build and then I do another build and I play against myself with 2 windows going on. Not bad. That's definitely what we're going to be showing today. If you don't want to do any third-party code or use any third-party libraries, that's fine. If you are up for taking a third-party library, there's a free one called Parallel Sync. And what Parallel Sync does is it lets you open 2 Unity editors that are referencing the same project. And you cannot do this with Unity itself. With Unity, when you open a Unity editor and you go to open another Unity editor, that second one must be a different Unity project. That's how Unity's designed to work. But if you want to have 2 Unity editors, or maybe even more, that are synced to the exact same project, that way you can do a little development, hit play, tab over to the other one and hit play. You don't have to do any building. And now you're using the Unity editor in the game window to play against yourself. It is the best way to develop games. Now, in 2022, that's our best option. In 2023, as I mentioned, there are some features that are 2023 only. There is Unity. I haven't played around with it too much, but I think they just copied kind of what Parallel Sync does in its workflow. And I think within one Unity editor, instead of having only one game window, you can have multiple game windows. So it's what's hinted at here. I have not played with this yet because I like to work on Unity 2022 or the latest LTS, in this case, Unity 2022. And when I make videos, I only make them about the LTS stuff. So this is something definitely to keep an eye out for. So let's go through and take a look at the demo. I'm going to be showing a few different things. So first, we're going to take a look at the Playground 2D, which is the name of this grassy field with a pig character and a crate to push. And we're going to look at the single player version. Here is the README for the repo, which you can get. I'm going to step through some of the points here. This is what the game would look like running in one of the modes. I've got a few different modes that I did, but the main point here is that to get from the planning through all 3 versions of what I'm about to show was about 8 or 10 hours. Then I spent some additional time to shoot the video as well. There's one project to download. It has a few different versions that I wanted to mention. has a single player version, a client authoritative version, and then a server authoritative version. And I wanted to kind of study the differences of those, as well as being able to compare the client authoritative and the server authoritative setup. Now, for a real production game, you'd only want the server authoritative one, because that's the one that properly routes all of the movement requests through the server for security's sake. So that's great. I've got some notes, some challenges, and some possible improvements here. And to get started with the project, you want to download it. You want to get the Unity editor version that matches, so you can see the Unity editor version there. For the single player experience, you're just going to move around with the arrow keys. You get some points for touching the crate. I'll show you an example of that. For the multiplayer one, just check the build settings if you're going to be running it. Make sure that the build settings only has the one scene that you want to test. So if you're testing the multiplayer client authoritative, just have that one scene be in there and build that, and then you can play the Unity editor version. And then also if you're going to be doing the server one. And for each of the spawned app builds, you want to hit H for hosting in one of them and C for client in the other, and then you can play against yourselves. I'll run through it, but just to go over the steps there. As a starting point, I use my own Unity project template, so you can check that out. It doesn't include code per se. It has a few code templates, but it talks about the best practices that I like for project structure. And then also in those code templates, the best practices I like for C# coding standards. And linked down below in this README, you can read my thoughts on that. I have some articles about that if you want to take a look. The different versions of the game are the simplest one, which is just without multiplayer. I have a single player version. I'll show you that. Then there's a client authoritative version. I'll just give a really high level about how that works, using some well-known hacks for doing it. And then the server authoritative really addresses the needs of this challenge, which is how to move around with server authoritative. My thoughts are here. Do I want to step through them? Yeah, I guess so. I'll mention some of the challenges. Actually, I'll pop back to this. So let's look at it, and then I'll pop back to the challenges in a moment. Now, here we are in Unity. When you first open the project, it'll automatically open this README if you care to look at it, or you can go to Window, RMC, and then look at this README file. So this is something that I like to include in my projects, especially when I'm explaining them, so that you can get a little high-level orientation. We've got a link back here to the repo for reading additional stuff. A little bit of highlights on the README docs. Reading the Unity's multiplayer docs rather, and then the different versions, and you can click here and it'll go right to the scene which relates to each of them. So let's look at the single player real quick. Single player setup here. So I hit play, I take the arrow keys, I move around, I touch a crate and it gives me some points. And if I push the crate off the screen, it snaps back to the center point. It gives you some on-screen instructions to touch the crate for points. So I really wanted to think of, okay, let me do the single player version first because I wanted to compare it to the multiplayer version. So that's it for that. Something of interest to take a look at there is just how the single player movement works. It uses rigid body to move, and it does that on fixed update. Now let's look at the Playground 2D. And this is the second version here where we have multiplayer set up in a client authoritative way. This means that each client is going to move its own character. And this is easier to develop, I think, especially as a newbie, and feels a little bit more like single player experience. But it's not really a realistic scalable solution, because when clients are in charge of their own game state, clients can be hacked. So as a player, if you're playing in an honest fashion, you would be able to just move using the keyboard input that's designed for you. But a malicious client, someone who wants to maybe get a better score than the rest, can fake their local state and be able to send that over the wire to the rest of the players. So easier to set up, but less secure and not really realistic for any commercial production. Let's take a look at that. And I will just run the local host here. So I'm able to move around as the host, push the crate, and this one works as well if you do a build and play against yourself, so you can do that. I'll do that for the for the server authoritative one, but this one works great. And a little bit of console log traffic there. So here in the quick lobby, you can turn on and off that logging if you want, which is something I set up. The world here in the scene is the UI, and I reuse that across all 3 of the scenes, as well as the background graphics and stuff like that. The main entry point here is the game scene server client authoritative. I think I won't show the code for this for the client authoritative, but you can dig into that if you're curious to take a look at it. So let's look at the player here. And the player has the transform, sprite render, animator, rigid body, box collider, all of the single. And then I have the network object added here, which is pretty boilerplate. The one thing I wanted to mention here is that the client network animator, the client network transform, those 2 are, I extended a built-in NGO class, and then I override one property, which it allows in a well-known hack for me to be able to move the player locally instead of only the host is able to move the host locally in a typical session. So if I take a look at that here, that in the client network transform, it extends the network transform and then overrides one property. So again, this whole client authoritative scene is a baby step on your way to creating something for production. This is not fit for production, but I find it is really easy to prototype around. And also when learning the fundamentals, it's a great place to start because it feels more like a single player experience. If you compare the player for the client authoritative and the player for the single player, they're quite similar in how they move themselves. Now we're going to jump ahead to the next scene and see in the server authoritative setup, it's quite different. And here we're going to take a look at the Playground 2D final time here. This is version 3 of the game, all within the same game project. And this is the server authoritative version. So here we're stepping our way toward a more scalable, robust, production-ready approach. And we'll talk about how the movement of the character is done a little bit differently here. This one I will run. So I'll go to my build settings and I will make sure that only the server authoritative one is set up there. And then I'll use Control B to build. So here in the built one, I'll be the host. And then here inside the Unity editor, I'll be the client. And now let's take a look at how it all works here. So as the client inside the Unity editor, I'm able to move around. Some things to give a note here are network variables are used for the score of each player so that the local player's user interface shows only their score. And the name given above each of the players is also done with a network variable so that each of the apps running can show the name of the other players in the room. And you can spawn, I think I've done up to 4. There's no limit to the number of players, but I spawn 4 windows sometimes to test. And it shows that and it works great. So here as player 1 on the client side, I'm able to move that crate. And here I'm able to move around as the host and also be able to move that crate. And if I push the crate off, then it snaps back to the beginning here. So everything's set up there pretty well. Is there anything I really wanted to shout out here? I guess I'll look at the player itself and just see how that's set up. And then that's the end of the demo. So in the player here, see some things I wanted to show. Here is the network variable for the player name and the player score. Pretty standard setup. Here in the network spawn, if you're not the owner, I disable the script. So pretty common way to have each of the pig characters running the player SA script, but only on the local machine does it actually run that script. On all of the other pig characters running locally here, if I'm not the owner, then it disables it. That's a pretty boilerplate way to do it. And I think it works great. So then I listen to the player's changes, and then let's talk about the movement. I think that's interesting. So what I've decided to do here in comparison to the client authoritative is that here, while I move, I take the input locally as shown here, I actually do the movement on the server. And that's done with remote procedure calls. So here I calculate the delta position to which position I want to move. So if I wanted to move upper right, that might be 10 and 10 inside of a vector 2, moving 10 in the X and 10 in the Y, and that gets sent as a move request here. So the move request here, what it's going to do is, I'll come back and look at the second case here, but it just tells makes a server RPC call telling the server, hey, I'm going to request to move here. So that's done in the first part. Then you have a method here that's flagged with an attribute of server RPC, and this is now running on the server. So any of the client pigs, any of the local pigs, let's say, I don't want to use the word client, any of the local pigs which have a movement they want to make, they ask the server, hey, here's a move server RPC call, and here's the position I want to move to. Then what the server does is it says, okay, here, tell the client with a client RPC call to actually fulfill that. Now here you could do some error validation, you could do some anti-cheat stuff, you could validate that, okay, the delta position is not absurdly large, stuff like that. So that's why this is kind of the checks and balances of having it run on the server. This also is going to tell all the clients that a given pig wants to move. So if pig number 1 is in the upper right corner on all the different app builds, and it says, hey, I want to move a little bit, then all of them move their local version of that pig up in the corner. So this also helps sync them all. And then on the client side here, we do the response to the move request. Again, I'll come back to these flags in a second. And here, what it's going to do is, let's say in the primary case, is it's going to move with a little bit of interpolation. Then we actually apply that on the rigid body moving to the new position. So I'm using physics movement here, which is not necessarily the requirement, but I think it's a cool way to do it. I've done that across all 3 scenes, so you can compare the rigid body setup in all of them. And then I do things like animate the local player character's frame to be running or not running. Then I wanted to circle back and talk about the interpolation and the running local. So let's look at the Unity scene again. Here in the player, I've added a couple extra flags here. So interpolation, just thinking out loud for myself, interpolation is the idea that a given local pig character is able to move smoothly to a new position, even if there's some network lags and stuff like that. So interpolation inside the, is it the network transform? There's interpolation built into that as well in some cases. But here I wanted to be able to move smoothly, so I've done a little bit of that myself. And you can turn that off and on if you want, and then do the build after that. And then I have this concept of is owner prioritized. Now, I don't really see a big difference if these checks are done. You do see something, but if you go to the network manager, if you want to fool around with it a little bit, and where is it? There's some debug settings here. So in debug simulator, you can simulate some slowness to the network traffic. So even though I'm playing myself on the local machine here, I'm simulating some different some delays and stuff like that. You could definitely play around with that and then come back to the player and try and check these on and off. The interpolation is going to move me, if I get information a little bit late, it's going to move me smoother to that new position. And then the is owner prioritized, let's take a look at where that happens in the check. This is something that I've seen quite a bit done in some other projects, and I think it's quite cool. And let's look at where that happens in the code. So what happens is inside when I'm about to request the movement, this part's going to tell all the other clients my pig wants to move. But then if I'm the owner and I have owner prioritized check, it moves me immediately to that new position. So it gives me the perception of movement before all of the other clients have actually updated to reflect my movement. And I think this is quite a common paradigm that I see in multiplayer development, is because the server gets a bit of an advantage that it's running the scene and the data syncing, so it actually gets updated faster than the rest, that the way you help compensate that is if you're not the server, if you're one of the random clients, you might want to have your local character look like its bullets are shooting a little earlier, or look like its own character is moving as we're doing here. So here I just immediately act like as if the server had told me to move. And it just for cosmetics, as the comment says. And then down here, when I actually hear back from the server, if I'm the owner and I'm owner prioritized, then I skip this step. So I'm sure not to move twice, let's say. And yeah, I was, as kind of my challenges and also my my possible improvements, I think this is an area to be thought about, and how to do this more elegantly across a larger scale, so that you could have this types of checks and balances, but maybe applied more universally across your movement system would be cool to look at. That's it. I loved talking about multiplayer in this project. Again, I am available for remote contract hire, and the flavors of that are as a Unity game developer, single player games, love to do multiplayer games, love to do VR, AR games as well. I'm getting into that. And then also available for hire as a Unity educator, creating online courses, creating in-person classroom experiences to teach the fundamentals of game development, as well as advanced things like software architecture, and also unit testing, and getting into best practices and how to implement them across your project. So again, thanks very much.